Now, okay, question number 7. Asadullah, can you start and read the question first, please?
OABC is a parallelogram. M is the midpoint of CB. P is the midpoint of AB. OA equals A. OC equals C.
And what's this? Read this for me, please.
Diagram not accurately drawn.
What's that mean?
So don't measure it.
Don't measure the diagram and make any influences from that. Okay, lovely. So let's get a nice red ink. Let's put this vector, make it a little bit more stand out. Okay, now, because it's a parallelogram, is there only one C in the parallelogram?
No.
Okay, now P is the midpoint. So if is this also C then?
Yeah.
Okay, but so what will this one be then? This one and this one here?
Would it be C?
No, it's C all the way across. So what would be halfway, A to P?
Half.
Yeah, half. Yeah, because all the way across is C. Okay, next one, we have M is the midpoint of CB. So similarly, if I go halfway, what's halfway up? The full way up is A. The full way up here is A. So what would be a halfway up?
A fifth.
Allahu
Akbar. A quarter, a quarter.
Whoa, half the way up would be a fifth and a quarter. Is everything okay? Halfway up is going to be a half.
Oh, yeah.
What's going crazy? Yeah, I'm doing about halves of my fifths and quarters. Okay, lovely. Right, now that we've labeled the diagram, we need to work out M to B. How do I work out M to B? Tell me what it is. M to B is simply what?
So half to M to B.
What is M to B? Everything okay, Asad?
Yeah.
Okay, don't forget we are making a video of this. Yeah, I might have to throw this video in the bin. Delete it. M to B is equal to half A, isn't it?
Yeah.
That's it. For us, we've already labeled it. It's done. Okay, what's M to P? So I need a path now.
So it'll be a half plus half.
M to P is going to be M to B, first of all, because we're going to go this way.
And B,
way?
to P.
That's right. So I need a root. So then it'll be P to B to P. Sorry. So M to B will be what?
Half.
A, and then?
There'll be a minus half B, C.
Fantastic. That can go here. Or you can take the half out first. And there we're done. Lovely. Okay. Now, the next question says show C to A is parallel to M to P. Now, M to P, we just worked it out. Do we know what C to A is?
No.
So let's work it out then. So let's go for, okay. So can you tell me now, C to A is actually this vector here. Do you know what that is?
No.
No. So what do we have to do then?
We have to find a path to it.
So give me the path.
So would it be C to M, M to B, B to P, and P to A?
Or couldn't it just be C to O and O to A?
Yeah.
Yeah, is that okay? So keep it the path simple. Okay, C to O plus O to A. What is C to O?
Half a whole.
So C to O is that way. What is C to O?
Would be just
minus C. Minus C. Okay, what's O to A now?
Would it be minus A?
It'll be plus A because you're going in the direction of A. It'll only be minus if you're traveling backwards, you're traveling in the direction that A is traveling in. So there you go, there's C to A. What do they want us to show? They want us to show that this vector here is parallel to this one here.
Yeah.
So what we can do here, we can actually rewrite the C to A and put the A first and the minus C afterwards. So it looks more like what we need to get to, which is that one up there. So hang on 1 second, let's drop this off here. And let's do some of this here. Okay, let's get back to, right. So what's the statement that we're going to make now? So is CA parallel to MP? That's the question I'm going to ask you now. So is this vector here parallel to this vector here, which is this one? Are they parallel by looking at it?
Yeah.
Yes, excellent. So what would be the wording now? What would you say? So we can say C to A is
Parallel to M.
Parallel to what?
M to P.
M to P. Because it is, what is it?
Parallelogram.
It is a so CA is a multiple of MP. So what is it? How is it a multiple? So we say C to A is equal to
2MP.
Yeah, because MP is half and CA is the full. So that means CA is double the size. There you go. Parallel. Done.
So, you know, every time it says show that.
Now, in this particular question, we say show that CA is parallel to MP. Because you have to kind of prove some two vectors are parallel, we need to put a statement in, like what we done in the previous question here, the previous one here, it said show that. We didn't need to write any sentences because the algebra and the vectors kind of canceled it all stuff out and we got to the answer. But in this particular case here, that what we're doing now, we got one part, if you look carefully, one part of our calculation here, one part over here. And so that sentence then ties it together.
Yeah.
So in this case, it necessitates a sentence. In the previous case, we worked it out all the way till we got to the answer and said show that, and we've shown it through the working out. But here, we've done some maths. We've done one bit of the maths here and one bit over here, all down here. So we need something to connect. So look, these two are connected by my statements. So you're making a statement here that this bottom vector is parallel to the top vector because it's a multiple of it. It's double the size. So you must write that sentence connecting those two bits of mathematics together. So that's
okay.
Yeah. So in the previous one, it's obvious. It's obvious in this question here. Look, when it says show that, we didn't do any statement. We've done lots of maths. So
yeah, so it kind of speaks for itself.
This one speaks for itself. It's kind of, we got there, but the other one's in two separate parts. So we got to kind of make them, we got to bring them together. Okay?
Yeah, that's fine.
So that was a good question. And alhamdulillah, we've got the other question there to kind of, to look at that. So we're just going to stop the video here for now and start a new one.